Welcome everybody to our OpenCV weekly webinar. And today we have a very exciting webinar because we are going to cover how to build and deploy your OpenCV application or any, even deep learning application as a web app. So I want to make sure that, you understand that this web app would not be production ready. This is mostly so that you can create a web app, share it with your colleagues, they can try out what you have built, and you don't have to show it on your computer, right? So you can quickly do something that allows them to try out what you have built. And for this, we have Vikas Gupta with us. And Vikas is basically the course director at OpenCV. He designs our courses, he manages the team, and basically he's the main guy for a lot of our, for most of our coursework. Welcome, Vikas. Would you like to, can you please introduce yourself?
Thanks, Satya. I'm really honored to be on this webinar. So I'm the course director, as Satya mentioned, and I have been in this computer vision and AI field for about 12, 13 years now. And I have been in various roles of teaching. I have about 4 years of as faculty in undergraduate studies, where I've taught various subjects like embedded systems, robotics, and various electronics and computer science subjects. And I have a master's from Indian Institute of Science in India, and that is in artificial intelligence and computer vision. And that was 6 years back. And since then, I have been working on various deep learning and computer vision roles. And since the last 4 years, I have been completely involved in creating online courses in computer vision and deep learning. So yeah, that's about it.
That's great. That's great. And people who do not know, IISc Bangalore is one of the premier research institutes in India. So getting into that university is a pretty big deal. And also with us, as always, is Phil Nelson, who is the content manager at OpenCV. He manages the webinar and does all the content work for us. Hi, Phil.
Hey, everybody. As a reminder, we will be doing Q&A at the end of the show with Vikas and Satya. Please use the Zoom Q&A functionality to ask your questions, and we'll try to answer as many as we can. We will also be doing a giveaway at the end of the webinar. Would you like to tell them what they'll win, Satya?
Yes, so the giveaway would be OpenCV for beginners. As you know, as some of you may know, that we are running a Kickstarter right now, where we are going to publish for our course, OpenCV for beginners. But in addition to that, you will also receive Computer Vision 1 introduction. So that is the first in-depth introductory course in computer vision. So we will combine these two, and the person who answers our question correctly, the first person who answers our question correctly will get this bundle of 2 courses. One, obviously, they can get immediately, but the other one, OpenCV for beginners, they will receive when it is released in July.
And don't miss out on that OpenCV for beginners Kickstarter campaign. There's a bunch of great deals on stuff at the various tier levels. I'll drop a link into the chat here.
Thanks, Phil. So Vikas, let's go over the outline. What are we going to cover? And then we will dig deep into each part of it. But let's start with the outline. What are the various things that we are going to cover first?
Yeah, sure. Should I share the screen?
Yes, you can start sharing the screen.
Is it visible?
Yep.
Okay. So today we are going to learn about creating 2 web apps and deploying it on 2 different services. So this is one of the web apps which we are going to deploy today. So this is just like a face detection app that we are going to deploy. And this should be the output. So this is the input image, this is the output image, and this is the threshold that we can set. So this is one of the apps, and let's go to the second app.
And the neat part is that you can build this app in just 1,000 lines of code, right?
No. So yeah. So it doesn't require 1,000 lines of code. It is after you have written the code in Python, it is just about 4 to 5 lines of code more, right? So yeah, that's about it. So we'll look at it. We'll look at what each of these components, how to add all these components. So in just about 5 minutes from now. This is the first app. The second app is this one, where we'll not load anything from our computer, but we will draw on this canvas. So if you see that if you draw something, so it looks like 2, and this is predicted class. It is 2 with 100% confidence. So we will also look at how to build this from scratch and deploy it on a service called StreamLit sharing. So this is about the things that we will be covering. Now, before even we start, I would like to give you a brief idea about why we are even concerned about this, and what is the motivation behind learning something like StreamLit. Why do we want to create web applications and deploy, right? So this is in general a machine learning lifecycle, right? So this part is the modeling part, where you have where you get the data. For any machine learning engineer, you get the data, you have a model, you train the model, and when you get good results, then you are supposed to deploy it, or somebody else is supposed to deploy it wherever the company wants, right? But you should note that this part comes at a very later stage, when you and all the stakeholders in the company are happy with your work, right? So this part involves a lot of iterations. Now, the problem is, when you are doing these iterations, you are involved in the development of the model itself, right? You don't create the slides, or you don't create the web applications to display it to the stakeholders. Now, what people do in companies is that they will create a web app, they will create the models, they will get good results, and then they will have to create demo videos to show it to their bosses, or they can create, say, slides, and they will take screenshots of their examples and outputs, and then they will have to share it with other people, right? So that is not a very tech savvy way of doing it, right?
Yeah.
So
and also people don't believe you, right? I mean, when you're showing slides, they know that you have shown the best results, even
right.
if you have not, right? Even if you're trying to show some, they want to try it out themselves.
Right.
And actually, this thing, 5 years back, or maybe 7 years back, these things used to be very difficult, and we would not invest, as through our consulting service, we would not actually build a demo app for a client just to show it, right? Oh, you just spent $2,000 on creating a demo app. So they don't like that, right? But if you say that, oh, I just spent an hour and this is a polished, app that you can try, that they don't mind, and this thing won't even take an hour, right? So it creates this demo for people who are not tech savvy. It could be your client, it could be your boss, it could be other students you want to share it with, if you're a student and you want to share it with the student community, to see how good you have built, right? They don't have to come to your computer to check it out, right? But at the same time, we are also saying that this app is not production ready, right? In production, you have to worry about a lot of things, including load balancing. You may need to optimize the performance of the model itself, etc. So it is somewhere in between. It's in the sweet spot where a machine learning developer, right, can actually create this demo app for other people, other stakeholders, right? So that's the sweet spot we are talking about. We're not talking about production, and we are not talking about expert web developers. In fact, neither Vikas nor I are web developers. Phil has a lot of experience in web development, but we don't, right? Okay, go ahead.
Yeah. So just imagine you are a freelancer. Difference between one freelancer who doesn't know these things, he is sending out a video. And if you are another freelancer who is tech savvy, who knows StreamLit and all, and he is sending out to his client, and the client is able to run his own examples, and they might run various type of examples, weird examples, and if they find it that everything is running fine, they will just be very happy with the product, right? So they will not have too many questions. So this is about the motivation why every ML engineer needs to learn about, say, deploying applications in the shortest possible time. And one of the various ways is using StreamLit. We'll come to that. So now we have all established that deployment is something that everybody should learn. Now, where do you deploy and how do you deploy? So these are the next two questions, right? So the deployment can take place in two or more manners. So one is you have a system, you rent a system on AWS or Azure or Google Cloud, and then you configure it, you have to install everything, and then only you can deploy your application that you have built on the cloud, right? So this model of deployment is called infrastructure as a service, where you are using the services, the cloud services, and you are only using the infrastructure. You are not using it as a service. The next type of deployment is basically platform as a service. So you use the platform, like the Google Cloud as a platform. They will have some inbuilt features in that platform that will take care of all of these configurations, and you will directly be able to upload your app and deploy your app. So this is called platform as a service kind of deployment. Now, all the cloud providers provide both these types of deployments. In today's webinar, we are only going to talk about, say, platform as a service kind of deployment and what are the options that you have. So this is about the where. So there are Microsoft Azure provides app service as a platform as a service option. Then Google Cloud has this app engine, and AWS has AWS Beanstalk, right? So these are the big options that these big companies provide for deploying your application in the platform as a service kind of environment. Now, this is about the where. Now we want to answer how, right? So you have to build your applications first, and the ways you can do it is you can use Flask, you can use Django, you can use Fast API, and you can also use StreamLit. Now, this is where we want to motivate StreamLit a little bit more, because what StreamLit is doing is that it is providing a completely Pythonic API, so that the ML engineers don't have to learn extra things like HTML, CSS, and JavaScript to create nice looking dashboards or nice looking web applications, which happens in, say, Flask or Django. You need to learn some more things to create nice looking applications, right? So this is where StreamLit shines.
Right.
Now,
because before we move forward, can I quickly summarize what we have covered till now, so that the audience is also with me, right? And I'm listening to this for the first time. So what you have said is that there are two kinds of services cloud service providers provide us. One is infrastructure as a service, and the other is platform as a service. In infrastructure as a service, they literally give you a Linux box or any kind of box on the cloud, right? And it is like you install everything yourself, you configure everything yourself. It is just a Linux box, but it's on the cloud. You SSH into it and do whatever you want to do, right? And the other one is platform as a service, where a lot of things are installed for you and you're using it as a platform. You don't need to get your hands dirty with everything. You pretty much get something out of the box. And we are going to focus on platform as a service. And now we are going to, in platform as a service, right? You still need to write the app. The platform is one thing, but on top of it, you still need to write the application where all the application logic will reside, all the HTTP requests will be handled, etc. And for that, we have various options. The most standard options used to be Flask and Django, those kind of frameworks, right? But now StreamLit is the new kid in town. And this is developed for people who have no web development experience. You don't even have to worry about HTML, CSS, JavaScript, etc. This is created for people who are only interested in, they know Python and they want to build a web application quickly without worrying too much about what's going on under the hood. Is that a fair summary?
Yeah, of course.
Okay, great.
Yeah. So this is all about the motivation, and that's the only theory that we would cover in this webinar. Now we'll jump onto the code, and so let's jump to the code. So StreamLit is okay. So let me go back. So basically, StreamLit is the fastest way to build and share data apps. Now, how do you install StreamLit, right? So it is just a Python package which you can install using pip install StreamLit in your virtual environment. So what I've done here is this is my terminal, this is my code window, and this is the browser. So we'll use it in this way so that you know what is going on all the on the browser as well as on the code window. So StreamLit comes, I have already installed StreamLit on my system in a virtual environment called StreamLit test. So I'll just run the demo example that comes along with StreamLit to see what are the possibilities that are there in StreamLit. So this is the demo application that is running right on my system. And here you can see that it is giving you a nice looking headers, and all those things are there. And then there is a sidebar as well. On the sidebar, you can choose what kind of demo you want to see. And suppose you want to see this animation demo, you are getting all these checkboxes, these track bars, this progress bar, as well as you can say you have these buttons. You can show the code, and many more things are there. So this is just to give you an idea about how it looks, right? So we will try to say replicate some parts of it, and you will realize how easy it is to replicate these things.
Yep.
So let us.
And all we did was we ran a Python script from the terminal, and it created the web server for us. It is running on localhost, and it's running the demo application, right?
Right.
So very easy, right? We are just literally, for Python users, they are literally running a Python script.
Yeah. Okay. So this is basically the demo application that came with this, right? So, but we want to build something. This is just say the next 5 minutes we'll spend in say freestyle coding, right? So we'll see what are the things that are available on StreamLit, and after we are done with that, then we'll go into looking at full-fledged demos and how to deploy them, right?
Okay.
So basically, you can just import. So since I have closed the window, it is showing that. So import StreamLit as ST. Now I'll just run this again. So now I have just created a file called streamlit app.py, and there is nothing else in this folder. And I'm going to run this using streamlit run and whatever the file name is, right? So that is it. Now it is running at this location, 8501 is the port number, and this is the app that is there. So since it is blank, I mean, we have not done anything, so that's why it is blank. So we'll keep on writing here, we'll keep on saving, and you will see that things will start appearing here. So there is something called title you can add. We'll say OpenCV webinar. So when we save this and run this, so this is the title that comes up. So apart from that, there are things like st.header. This is the header, and we save it. We can see this. Apart from this, there are say st.fileUploader. If you want to upload any file, you just have to include this, and there will be a file uploader that appears. You can
it's
upload
beautiful
files.
Looking also, right? So the nice thing is that it's pretty looking.
Right, right. So st.fileUploader. Now let's give it a variable. So this is basically, say, the file name, and let's upload something. So say this is the demo image that we have uploaded. So it has gotten uploaded, but we have not done anything with that, right? So what we have to do next is, so these images, all the images that you load, they are in PIL format. So now you have to import the PIL library, import PIL. So from PIL, import image, and this is the file name. So say we take this file name and image.open file name. And so this is just the PIL Python code. Now we have to actually show it. So there is function called st.image, and we can show the image, right? So this was it. So you can browse files, you can browsing the file, you get the file name. Using the file name, you can open the image using a payload library that will return it in a NumPy array format. And this st.image, this also accepts NumPy.array format, and it will show the image as it is, right? So this is the first thing.
Vikas
now,
is also teaching us about product placement. You know, in movies they put Coca-Cola in the right place, so that as an advertisement. Okay. Sorry. Go ahead.
Yeah. So it's time to remove it then. So yeah, so this is the most important thing that most say computer vision engineers would be looking for, right? So as you can see, it's like just one line of code and you get the image handle, right? So once you get the image, that's it. You have your own algorithm, you have your own functions that does all the things and that does all the processing once it gets the image. And once it gets the image, whatever you do, like you have to plot it, you have to give some predictions, that can also be handled directly here. So we loaded the image and we displayed it, but instead of that, we can also get display other things, like we can write something like st.write prediction. So whatever you write here, this is going to display. And it's not just text. You can write anything. Whatever you write here, whether it is a Python variable or it is an image. So say, for example, if we go back. So if we don't show it as an image and we just show it, we just write it. So
so it gives us the size of the attributes of the image.
Yeah, I mean that is there, and okay, maybe we need to get the data. So yeah, actually that was a mistake. Maybe we should. There might be something else that we have to do. So that's about it. Now there are other StreamLit functions that we can use, like st.checkbox. So where you can specify the label that is, say, this is the navigation, and inside this you can specify whatever names you want. So you want to give demo 1, demo 2. Oh, this is checkbox. This is select box. So yeah, so if you want some selections, you can get demo 1, demo 2. You can get these kinds of select boxes, and you can also get other functions like radio buttons. You can get submit buttons and all those things.
Yeah, so much better UI compared to, say, High GUI, right? Which is not really meant for building UI applications, but this gives a very good option to build nice looking UIs and sliders and checkboxes, drop down menus, etc.
Right, and it doesn't require so much of code as well. I mean, it's just one function, and you get all the data directly in the Python format. You don't have to have multiple functions going from HTML to Python and all.
Right.
So yeah, so this is, I'll just go back and just use this app as it is and try to deploy it, right? So this is currently running on localhost 8501. Now, there are multiple ways of deploying it, as we talked about. Like there is, okay, so there are other ways like App Engine is there, App Service is there. But apart from that, there are other free resources also available, which are pretty famous. Like there is a Heroku, there is StreamLit itself. StreamLit themselves have their own sharing platform called StreamLit Sharing, where you can upload their app and without any other configurations, you can deploy the app. And then there is another lesser known way of deploying it directly from your own system. That is, we can use ngrok. So there is something called ngrok in. So there is something called ngrok. What it does is it is like a reverse proxy. So it will take your local host, where whatever port you want to say expose to the internet, it will take it and create create a new link or create a new IP address, and it will share it, right? So this is very easy, because if suppose you don't want to put it to GitHub, or you don't want to go through the hassles of deploying an application using any other software, you just want to use your own system to deploy it, and it is very fast, right? So you just have to you just have to log in to ngrok. So you just have to register and log in. Then it is a two-step process. You can download ngrok, and the second step is you have to authenticate your token on your system. So this is the only command that you have to run in order to deploy your application from your own system, right? So I'll just show it to you. This is the command. I have already downloaded it, and it is, the binary file is already there on my downloads folder. I will not show it to you because there are other things as well. So this is the command ngrok authorization token, and this is my token. And if I run this, this will get saved. And the next command that you have to run is ngrok http 8501. So now we come back to this. It is running on 8501 on my local system. And if I run this, then it will create its own, it is going to create this link, which can be accessed from the internet, right? So for example, if I paste it here, so initially it takes some time. So this is basically, yeah. So because we have showed an image and there is no image, that is why it is giving an error. But if you browse the file and go back to this, so it will be able to show the image. So if we have been able to deploy our application that we have just built in 2 minutes using this tool, right? Obviously, this is not the most robust way of sharing your app, but this is another good way if you are looking for a quick and easy solution, right? So this link, you can, anybody on the internet can access this link.
Yeah, just to give you a little background, you should probably never use this option if you're running this thing off of your laptop, which you're probably going to close or something like that. But let's say you have a Linux box in your school, or you have a Linux box at your home, and it is always connected to the internet. Then you may want to, you can use this, and it has a reasonable internet connection. Then this is a pretty valid way to do it and share it with the world. What a reverse proxy does, for people who may not know, is basically your IP address can change, right? the IP address that is assigned to you most of the time is dynamic, right? And when you use a tool like ngrok, it makes sure that that IP address always maps to this URL. Even if your IP address changes, it actually maps to this URL. So yeah, but it's keep in mind that this thing is running off of your computer, right? And there could be security issues. Everything has these ups and positives and negatives, and then it is also limited by your network, how fast the network is. So yeah, so you have to make those choices. Now let's learn how to do it not on your machine, but onto a remote server. Okay.
Yeah. So yeah, before we go there, we will like to look at a better application. This was just a very simple application. I would like to show another application that we have. So let me first, okay. So this is one of the applications that we are building for our course as well. Now here we have given options of trying out all the things that you might learn in the course. This is still a work in progress. So basically, this is also showing you what are the possible things that you can do, right? So for example, if you want to do image processing, you can just load any file. So this will load, and you want to do grayscale image, you want to do image negative, you want to do blurring, if you want to change the size of the kernel, you want to see the different types of algorithms that you can apply on the single image. The image stays same, but all the functions that are there, it changes, right? So here, this is one of the nice applications. Now, as you can see that since I changed to edge detection, and edge detection has more examples or more methods than in general. So here we can see that, so you chose edge detection and then you chose canny detection. So here you can say change all the higher threshold, lower threshold to get different types of images, right? So this is like you can check in anything in any example. And so this is, for example, a face detection demo, and we can build all the demos in the single StreamLit app, right? So that's one of the demos. And now it's.
So one of the things I think for students, the projects you do, if you're looking for a job and you present it in this way, oh, look, these are the projects I did. It creates a very good first impression that, oh, it's presented very nicely, all the various things that you have done. And it's really not a lot of work to get this thing up and running.
Yeah. So this was, I just wanted to show a concrete example, because the example that we show, I mean, if I had continued doing this, it would have ended, it would have taken 1 hour to show all the features. So I just wanted to show the features that are there that you can use for StreamLit for. And this is more than enough for most of the application developers, right? So yeah, so with this, I'll stop this demo, and we will start with the second demo that we had discussed about the
face detection one, right?
Yeah, that's the first one. So so we will see how to deploy it on Heroku as a platform. And so this, I'll just show you the code first. So for this, basically what I did was we already have a code on, say, OpenCV. And I just want to show how easy it is, right? So We already had the code for OpenCV face detection. We had written a blog on that. Now we wanted to create a face detection demo on StreamLit using that and see how fast we can do it. So it took me around 5 minutes to say convert that code into a StreamLit app. So what are the changes that we did? So all these things were already there, right? So CV2, NumPy, image, PIL, all these things are already there. This let me show you what the so basically this is the model loading part. So we are using a cafe model for detecting faces in the images, and cafe model has generally two files. One is the cafe model, which has the weights, and the prototext file, which has the configuration, right? So for loading the model is as simple as read net from cafe, and you pass all the configuration file and model file, and you get the network, right? So this is the first part, that you have to load the network. Now, once you have loaded the network, obviously the first thing that you had to do was create this thing, the file uploader. So you have the file uploader, you have loaded the model, and if the uploaded file, if there is an uploaded file, then you go through this. So basically, what you're doing here is you are converting the image into a NumPy array, just resizing it for giving it to the network. And these are all just placeholders for showing these images, right? So this is the function that we are actually using. We are passing the network, we are passing the image, and we are passing the confidence threshold. Now, this is the confidence threshold slider, which we have specified here using st.slider. So this is the first, this is the second StreamLit function that we have used. The first one is st.fileuploader for this one, and the second is the st.slider for getting this. Now, I don't want to go into the OpenCV DNN part for detecting faces. I'll just go about it in just as an overview. So basically, what we do is we are creating a copy of the actual image that we got. That this is the image, and then we create a blob which is required to be fed into the network. So this is a blob, and this we set the input of the network to this as the blob, and then we do a forward pass to get the detections, right? And once we get the detections, we can get the bounding boxes. So all this code is just to get the bounding boxes for each of the detections. So all the detections that you are seeing, these are all inside this for loop. We are finding all the bounding boxes for these detections, and we are creating the rectangle around this in green color. And finally, this image, the image that we are getting after adding the rectangles on the image, that we are returning to it, right? So once we have got the output image, we are just showing the output image here. So this is just the demo. So what we just to summarize, what we did is we took the code from yeah. So basically, we took this code from this repo, this blog post, and you can see that this was the exact same code that we had taken. We just added 3 to 4 lines of StreamLit code, and we got this kind of an app, right? So now that you have got the app, the next thing is to deploy it, right? So to deploy, we need so for deploying, we can either deploy it on StreamLit sharing, or we will deploy it on Heroku. So for this example, we will deploy it on Heroku and C. And for another example that we are showing, we will deploy it using StreamLit sharing. So we already saw this. This is being already deployed using the Heroku app. Now we are going to see how we do it, right? So Satya, do you have any questions?
No, so I mean, you already summarized it, but the thing to notice, and I'm pretty certain that everybody must have noticed it already, is how little the code was modified. most of the code that you're looking at, it is the code that we had written as a Python script as such, just for running it as a Python script, right? Now, with just 5 lines of code, I would say, 5-10 lines of code, this becomes a web app for you, right? That's pretty amazing, and a nice looking web app at that. So
yeah, so it's like 6 lines of extra code that comes for StreamLit. Okay, so yeah, coming to Heroku. So for both of these, for Heroku or wherever you have to deploy, right? Even for ngrok, you had to actually first create an account or log into the account, and then only you could deploy it. So the same goes for Heroku as well as StreamLit Share. So for Heroku, you have to create an account. I have already created an account, so let me log out. So basically, you have to create an account from this id.heroku.com/login. So here you can go and create an account, and once you log in, you will be able to see a dashboard, and from there you can create your web apps or deploy your web apps, right? So now the first step that you have to do for deploying your web apps is you have to create a GitHub repo. So this is not mandatory. You can also do it from your local system, but there are multiple ways of deploying on Heroku. One is using your command line, and the other is using their own interface on the desktop. So we prefer to do it through the desktop. So this is already the app that has been deployed, and so this is how the dashboard looks for a deployed app. Now, let us first go through the GitHub repo that we had created. Now, you can see that this is the StreamLit Python file that we had created. This is the model file, the cafe model, and this is the deploy.prototext file. So there are 3 new files that you can see. One is the setup.sh file, one is the requirements.txt file, and one is the proc file. So these are the 3 files that you would need if you are deploying anywhere, or these are at least the 3 files that you will need for the deployment on Heroku. Now let's see all the files one by one. So first of all is the requirements.txt file. It lists down all the Python packages that are required. So when you are deploying on Heroku, it will see all these Python packages and install it on its own, right? So that is where the platform as a service thing comes in. You don't have to install it, but they will install it just looking at this file. So we will install NumPy, StreamLit, OpenCV Python headless, and StreamLit drawable canvas. So this is not required, but these are the 3 files that is required. So this is the first file. The second file is the setup.sh file. What this file will do is this is a shell script which will run on Heroku when you are deploying. And what it will do is it will assign the port, it will create a folder for StreamLit app, and it will add all these configurations to this TOML file, right? So this is the second file that you have to add. And mostly these are the configurations that you have to do, and that is it. And apart from that, there is this proc file which tells what to do, right? So this is the process. This is the web process that you have to do. So it is saying that execute the setup.sh file and run the StreamLit app. So remember that this is the same command that we had used for running it on our local system as well. So the extra thing that we have to do is to configure Heroku to take the right ports, as well as some other configurations which StreamLit requires, and then run this using the proc file. So these are the 3 new files which I have added. You can have a look at it. We will share it with you. I think Phil has already shared. So these are all the files that are required to actually deploy it using Heroku. So let's see how to deploy it. So you go to new, create new app. We can name it anything. So I'll just name it test StreamLit phase. It is available. That's good. Then create app. Now, this is not going to create the app, right? So first of all, you have to link your GitHub. So that is why I have already uploaded the code, the whole folder into GitHub. So we will be using the GitHub deployment method. And since you select GitHub as a deployment method, I have already connected my GitHub to Heroku. So when you are asked to connect, just follow the steps and you will be able to see, just follow the steps and it will be connected to Heroku. Now search for all the StreamLit based application that I have added to my repo. So this is the StreamLit phase detect Heroku app that I had added. So I can just connect it. So it is able to find it and it is taking the main branch, and I have kept it in the main branch. You can also select if there are other branches and then you can deploy the branch. So you can see that it has already started deploying it. It has started to install Python, right? So this is what we were saying about platform as a service, that there you don't have to install anything apart from giving a requirements.txt file and proc file, right? So it will take care of all the installation. As you can see that it is installing all the required libraries, all the Python packages that were provided in the requirement.txt file, and also their dependencies as well. And obviously it is going to take some time to install all the dependencies. And once the dependencies are installed, it will deploy it successfully if it is successful, right? So hopefully it will be successful without any errors. It takes about 2 minutes to deploy this.
Yeah, so it's a good time to, while it's deploying, it's a good time to summarize what we have done.
Yeah.
So we took our application, the face detection application that can run on a desktop, right? It's a simple Python script that we modified it to become a web app by just adding 5 or 6 lines of code, right? And now this modified app was running on our local system using StreamLit. Now, what we want to do is we want to deploy it so that other people on the internet can use it. And we had 2 options. The first option was to run it from your local machine, but expose it to the world. And that was one option, using a reverse proxy. And the second option we used, which is probably the preferred option, is use Heroku to do this deployment. And to do this deployment, all we had to do was add 3 more files to the application and then connect our GitHub repository to Heroku, and boom, we are all good, right? Hopefully this application succeeded. Otherwise the summary would not make sense.
Yeah. So here you can see all the things that happened, and finally it is saying that deployed on Heroku and your app was successfully deployed. You can click on view and go to the app, and we already checked how it works. So let's just check once more. Yeah. So okay, here with the help of this threshold, you can run it with different thresholds and see how your algorithm might have behaved if you had changed the threshold to something else, right? So if you put a high threshold, then obviously these pieces will not be detected. So yeah, this is about deploying on Heroku. It's very simple. Yeah. You just have to create an account on Heroku and have some 3 more files on your GitHub repo. Write a few lines of StreamLit code, and you are done. Yeah. So this was about Heroku, and I would also
do we actually have time for the second one? We just have 10 minutes, and we also need to go into question answer. Okay. Or could you summarize quickly for the other app? I think more important for the
yeah. Okay. So yeah, we would not go into that if it's only 10 minutes left. So I'll just show you how to deploy using StreamLit share, right? So
Okay.
assuming that we have already got the this thing. So this is the file, right? So it is even easier than Heroku. That is the main thing that I want to convey. So we have the README file is there, requirements.txt file is same. StreamLit is the app, and the only thing, okay, so the only thing that you need is the requirement.txt file. You don't even need the setup, or you don't have to know how Heroku works, right? So basically you had to add a proc file and a setup.sh file that you see here, because you have, I mean, Heroku won't work otherwise. So StreamLit has gone one step further to even make it easier that you don't have to add any other file except for your repo, right? So that is it. And it is even easier. You can just link GitHub. That is the first step. And then you can create the new app. Once you have linked the GitHub, you can see all the GitHub repos that are there, and then you can deploy it. So the deployed app is, it was here. So this is how it looks. You can also try it out we will give you the link for this, and following the same instructions, just go to the share.streamlit.io and you will be able to deploy it. The only thing is that StreamLit sharing is only by invite right now, and they just take about 1 or 2 days to share you an invite. But once you have got the invite, you can deploy up to 3 applications. One more thing is StreamLit deployment is better than Heroku in terms of the resources that they provide. Heroku provides about 500 MB of RAM, and StreamLit provides about 800 MB of RAM. And they also provide 7 days of idle time as compared to 30 minutes of idle time on Heroku. So these are the major things that I would like to cover with StreamLit and StreamLit sharing. And we'll just summarize. And before that, we would like to take some questions if there are.
One other thing, Vikas, could you name we are using a canvas to draw on that HTML page, right? Could you tell users what, that pip package that allows you to add that canvas to your StreamLit application?
Right, so that is very important. Yep. So this is a StreamLit drawable canvas, which allows you to have things like these. You can add a canvas to the StreamLit app. And this is just one very basic example, right? You can, if you think about it, you can create image annotation tools with this canvas, right? So you load the image on the background, you can load the image, and you can do face key points annotation. You can do segmentation. You can do bounding box annotation. You can do any kind of annotation just by using StreamLit and StreamLit drawable canvas. So this is a kind of very powerful library as well.
All right, so we are ready for questions, but are we ready for the giveaway question?
Let's. Would you like to remind them what they'll win if they answer the question correctly?
Yes, the win is again OpenCV for beginners. They will get a free copy of OpenCV for beginners and Computer Vision 1, which is the in-depth computer vision course. And Computer Vision 1, they can get access to immediately or whenever they want. And OpenCV for beginners, on the other hand, they will have to wait until end of July to get access to it, because we are still in the process of building that course.
Yes, and so as a reminder, the way this works is I will ask a trivia question based on the slides from the presentation here. The first person to answer in chat on my screen will win what Satya just described. So during the demonstration here, there was a face detection app running. How many faces were detected at a threshold of 0.5? Ooh!
That was fast.
All right, it looks like Ike, or Ike, one here, or no, that's wrong. Luis Alberto is the first one to answer the correct answer, which was 5 faces. Congratulations, Luis.
I think we will also convert this, into a into a blog post so that people can follow this three. Unfortunately, we did not get a chance to go through the Canvas application, which is also very exciting. But we will, maybe a few weeks later, we will convert this thing into a blog post so that people can follow through.
Yeah, and so we'll do questions and answers now. First of all, several people have asked if we'll be posting this on YouTube or somewhere else. Yes, it'll go on our YouTube channel. I'll drop the link in the chat here again in a moment. All of the other previous episodes are available on YouTube as well, along with, for most episodes, we link to, say, Jupyter Notebook or whatever other code sources there are, so you can follow along after the fact. One of the common questions we got today, people asking about different services. Can you use AWS with this setup, or is it limited to the ones we discussed?
So you can, as we discussed, you can deploy your web applications on any service. It's just the level of work that you have to put in is the least in ngrok versus everybody else. So obviously ngrok will take up your system. So if you want to do it on a cloud service for free, then you should go for StreamLit or Heroku. But if you are not happy with the resources that they are providing, say suppose you want GPUs or you want more CPUs or more RAM, and your application demands that, then obviously you have to go for something like Google or AWS or Azure. So that is where the infrastructure as a service or this platform as a service, the things that we talked about, App Engine is there, App Service is there. So these are the services that you can use on these cloud service providers as well. So this application can be deployed anywhere. It's not just limited to, say, StreamLit, Share, or Heroku.
Great. Thanks for that answer. A couple people have asked about what are the limits of what kinds of models that can be run using this method? Like, are there any functional limits in terms of memory, compute, that sort of thing?
So yeah, that's what I mentioned in the previous answer as well, that Heroku and StreamLit Share, these provide a limited quantity of resources in the free tier, and they also have their own. I mean, StreamLit does not have, but Heroku also has their own tier, right? But now Google and all these big cloud providers, they also have come up with similar app services which you can use, and most of them also provide, say, when you sign up for these services, you also get, say, $200, $300 of free credits, which you can use for basic services, not using GPUs, right? So you can use, and there is no limit to what you can use if you are ready to pay, right? So that's the thing.
For GPU, you'll have to use cloud services, right? Azure or AWS or a GCP. Yeah, for GPU instances, for the models that require GPU instances.
Yeah.
Thanks. A couple people also asked, this is interesting to me as well, do you have any suggestions for how you could do some like this using videos instead of images?
Yeah, it can be done with videos as well. We didn't describe that, but it can be also done using videos. It's just, so instead of st.image, you have to do st.video, right? So it is as simple as that. And for loading part, it is same. So file uploader will load image, video, whatever you want. And inside that, there is Python code which will handle your video. And for the output, you have st.image. Instead of that, you just do st.video, and it will work.
What about webcams? What about live streaming?
Yeah,
video?
webcam also works in the local system, but it won't work directly on cloud, right? So on the cloud, you are not able to see the webcam. But you can use things like WebRTC for accessing webcams on a different server, right? So you can, so basically, suppose you have deployed the application on AWS, and somebody else is trying to use their webcam for getting inference, then for that you have to use WebRTC. There is another good library that someone has created. I forgot the name. But there is a good library which can handle StreamLit specifically. So there is a library, StreamLit WebRTC or something like that, which you can use along with StreamLit to handle the WebRTC part. right? So that will take care of the webcam part even when you are doing it on the cloud.
Great.
So Phil, we should just get that name afterwards, and when we upload it to YouTube, we should put that link in.
Yeah, we'll include the RTC for StreamLit. Vikas, how can people get in touch with you if they have questions or if they want to learn more about OpenCV courses?
Yeah, you can, if you have questions about OpenCV courses, you can email at courses@opencv.org. That is our official email ID for courses. And if you have any questions directly, you can send it to Vikas at learnopencv.com.
Awesome. Thanks. I guess we're out of time here. Satya, you want to take us home?
Yeah, thank you so much, Vikas. It was a pleasure, you instructing people on how to do this. People have, people who have taken our courses are already familiar with the work you have put in, but I guess this is the first time you're coming online to do a presentation like this. So
yeah, it is the first time I'm doing it ever.
Right.
Well, you did great.
Yeah, that's great.
Yeah, I hope so. I hope so. People liked it. So yeah, I would like to end with just a note that we should all be very thankful that we are in this era where AI is booming. So we should all be very thankful that we are the AI engineers in this era, which is kind of booming, and there are other people in other fields who are not getting to enter in this era just because it's not trivial to enter from a different background. But it is still possible if you are ready to put in your time and efforts. So yeah, at least 6 months to 1 year, and you can completely change your domain to AI. So that is something that I would like to end with.
That's great. And thank you, Phil. And a reminder to all our listeners, audience here, that our Kickstarter campaign, I think there are some 8 days or so left. And we just hit our first stretch goal. So anybody who is actually backing us will receive a free Python crash course for which will be enough to learn about good practices. We will cover NumPy and Matplotlib, and it will be available for free to all the users who have backed us in our Kickstarter campaign. And that is all we wanted to cover in this webinar. Thank you so much for joining us. We'll be back next week.
That's right, 9 a.m. sharp. Our guest will be Anna Petrovacheva with a special presentation. You won't want to miss it.
Okay, bye.
Thank you, guys.
Thanks so much for watching this episode of the webinar. Please hit that like button, subscribe, and don't forget to tap the little bell icon to be notified when new episodes drop. If you'd like to be in the audience next week, subscribe to the OpenCV newsletter.